For section 2.7b, we're looking at the last thing we can do, which is stretch or shrink. And shrink is synonymous with compress. And your book uses shrink, but I prefer the word compress because I think it gives a better visual of what's happening. That's supposed to say compress. But we have two versions of this. So we have a vertical and a horizontal. Vertical is if we're multiplying the function by a constant on the outside. There are two options here. If the c is bigger than 1, excuse me, if the absolute value of it is bigger than 1, sorry, then it's going to be a stretch. And if that absolute value of c is between 0 and 1, then it's going to be a shrink or a compress. Let's look at this case first, and then we'll look at horizontal in just a second. So on number 1a, 6x squared. So 6, the absolute value of 6 is 6. 6 is bigger than 1. That's going to be a vertical stretch. So I'm going to say a vertical stretch by 6. So what does that mean? That means that we still have our origin point here for the parabola. Usually we go over 1 and up 1, but since it has that multiplied by 6, we're actually going to go over 1 and up 6 to stretch it by 6. So I'm going to go left 1 and up 6. And I also will go right 1 and up 6, which is going to make it a much skinnier looking parabola. It's been vertically stretched out. For letter B, -1/6. Okay, so this is why the absolute value part comes in here. If I take the absolute value of -1/6, it's 1/6. That is between 0 and 1. That means it's going to vertically shrink this graph. So this one is going to have a, I guess I should have put stretch on that other one because they both start with a S, vertical stretch. So this one's going to be a vertical shrink by 1/6. Don't forget about the rules we learned in the last section. The negative out in front is going to X reflect it. So this one will be facing down. Still going to have my origin point. But now, what does it mean to vertically shrink by 1/6? Well, now, instead of going over 1 and down 1, it's only going to go over 1 and down 1/6, just a tiny little bit. Now, that's hard to draw, so this is another one where it's a good idea to plug in a point, do an XY table. A good number to pick for X in this would be the number 6. Because if I square 6, 6 squared is 36, and I times that by -1/6, that's going to give me -6. So at 6 -6, right down here, I have a point. And I know the parabola has a symmetry to it. It has that y-axis symmetry. So if I go to the other side of the y-axis, now I'm going to have a parabola that has been vertically shrunk or vertically compressed, making it look wider. The other option that can happen is if we multiply inside of the function, if we multiply just the x by some constant. This is going to be a horizontal stretch or shrink. Now, what happens is the rules actually change. If the absolute value of c is bigger than 1 here, that's going to be a shrink horizontally. And if the absolute value of c is between 0 and 1, that's going to be a stretch horizontally. Now, while that seems like, oh, we're doing the opposite of what we just talked about, really these two things are really doing the same thing. If I squeeze something together horizontally, if I shrink it horizontally, that's really going to be the same thing as stretching it vertically, and vice versa. If I stretch it horizontally, that's really the same thing as compressing or shrinking it vertically. So basically, here's kind of the general rule of thumb. Numbers bigger than 1 are going to make it skinnier. So these are going to make things skinny. And numbers between 0 and 1 are going to make it wide. Kind of as a general rule when we're looking at these. So on letter C, this 4, okay, 4 inside there being multiplied to x. 4 is bigger than 1. That's going to be a horizontal shrink. So this is going to be a horizontal shrink, but really a horizontal shrink is a vertical stretch. And then 4 is going to move it down 4. Now, again, there's a lot of stuff going on here. This is where I strongly suggest making a table. So if I picked 0 for x, I don't want to plug in any negatives for x because I know that's going to give me the square root of a negative, which I don't like. But if I plug in 0 for x, I would have the square root of 0 minus 4. So that's going to be negative 4. So I've got a point down at 0, negative 4. 1 would be a nice number to pick, because that would give me the square root of 4 times 1, which is 4. So square root of 4 minus 4. So that's 2 minus 4, negative 2. So 1, negative 2. And I need one more point. 2 would not be a very good pick, but 4 would be a nice pick. And again, I'm saying nice pick because it'll give me the square root of something simple. So if I put 4 in for x, that would give me the square root of 16 minus 4. So that's 4 minus 4, which is 0. And I get my square root graph. Oh my, let's try that again. That was way off there. All right, let's try that one more time. My square root graph. There we go. Better. Not great. But it's been, again, horizontally shrunk or squeezed in horizontally, which does mean vertically stretched. And I can see that this does look skinnier because my normal one looks more like that. This one is more stretched vertically. So again, make those tables on these, and that's what we're going to do on the remaining problems as well. So on letter D, let's think about what's happening to this graph so we have a good idea of what numbers to pick. The minus 4 is going to move me to the right 4. Multiplying the function by a 2 is going to vertically stretch this thing out by 2. And then the minus 1 on the outside, that's going to move it down 1. So I do know where my vertex is, right 4 and down 1. So I can put a point there, right 4 and down 1. Now, the reason I like to know where that is, that's kind of my starting point. I want to pick x's on either side of that starting point. So let's say I pick, so that's x is 4, so let's say I pick x is 3. If I plug 3 into my function, remember to square first, so that would be 2 times 1 minus 1. So that's going to give me 1. So I'm going to have a point at 3, 1. And then I want to pick something on the other side of my vertex here. So if I pick 5, if I plug 5 into my function, it's going to give me 2 times 1 squared minus 1, which will give me 2 minus 1, which will also give me 1. And so I get the parabola, but it's been stretched out. It's a little skinnier than normal. For letter E, let's see, I've got a negative on the x. That's going to be a y reflect. I've got a 1/3 out in front of the machine that's being multiplied. That is between 0 and 1. So that's going to mean a vertical shrink. And lastly, I have a minus 5. That's going to move me down 5. So again, it's good to know where am I starting. This thing, as far as shifting, is only going down 5. Now, note that I'm reflecting it over the y-axis. Well, remember, this is absolute value, which looks like the V shape. If I fold that over the y-axis, nothing actually changes. So just be aware, when I graph this, it's still actually going to be facing up. Reflecting this over the y-axis doesn't really do anything. So again, it's a very good idea to make a table of values. Now, my x is 0 for my starting point, the one I already graphed. But I don't want to just pick -1 and 1 because I know I'm going to be multiplying it by 1/3. So I'm actually going to pick -3. And so I'd have, let's see, do it down here on the bottom. I'd have 1/3 times the absolute value of -3 minus 5. So that's going to be 1/3 times 3. So that's going to be 1 minus 5, which is -4. So at -3, I'm down at -4. Another smart number on the other side of it would be 3 to pick, because it's going to give me the same thing. I'm going to end up with -4 for the y. So write 3 down 4. And I do my little absolute value stuff, which it does look like it's been shrunk vertically or made wider. For the last two problems, now we're going in the reverse. I'm giving you the equation. I'm sorry, I'm giving you the graph. You're telling me the equation. So you can call this y equals or f of x equals. I'll go f of x just so we use that function notation. All right, well, we know this is square root, or we should be able to recognize that that's square root. And let's think about it. Normal square root goes this way, but this square root is going the opposite way. That tells me that there's a y reflection. So a y reflection means that I have to have a negative on the x. If I test this point, and this is why I gave you this specific point on here, this is saying if I pop in -4, this thing should tell me 1. Well, if I try that with this, if I pop in -4, that'd be the square root of 4, which is 2, but it's supposed to be 1. So something's wrong here. I don't quite have the function the way I need it. Well, what's happening is this is being vertically shrunk. I need a half on this. I can tell that this thing usually goes 1, 1, and then 4. I don't need a dot there, I'm sorry. Usually goes 1, 1, and then 4, 2 for its other point, if this were to keep going. But it's only going 4, 1. So it must have been smashed down a little bit. If I test, and this is why, again, I give you this point. If I test now, if I plug in -4 into this function, I'd have 1/2 times the square root of 4. Square root of 4 is 2 times 1/2 is 1. I did get the y coordinate I was supposed to get, so that must be my function. For letter B, this looks like absolute value. But let's see what's happening here. This has been flipped upside down, so that's going to be an x reflect. So I know there's going to be a negative out in front of it. I've shifted to the left 1 and up 3. So how do I account for that? Well, with absolute value, or any function, sorry, left 1 would be x plus 1. Up 3 would be a plus 3. I know it's facing the opposite direction. It's flipped down, so there's going to be a negative out in front. And the last thing deals with that stretch or shrink stuff. Normally, it would be going like that if it wasn't stretched. But since it's been stretched, this is going to have a 2 out in front. And again, I can test to see if that's correct by plugging in this x value here. So if I take the function I have, -2 absolute value of -2 plus 1 plus 3. So that would be -2 times the absolute value of -1, which is 1. That's -2 plus 3, which is 1. That is the y coordinate. So there's my function.